Okay. All right, so let's start at the beginning at the top of the notes here. When you have a denominator that is an irrational binomial, irrational means you've got the square root sign. Binomial means you have two terms. Okay? It says when you want to rationalize a denominator that has two things added or subtracted, you have to multiply by what they call the conjugate. Okay? And you guys know how to do this. The conjugate is the exact same thing as the binomial, with where the sign has been reversed. When you multiply a binomial by its conjugate, you will always get a, quote, rational expression. So I want to take you back when we were doing some factoring, okay? Remember when we had two sets of parentheses that were identical, but one had a plus and one had a minus? What happened to those? There'd be no middle term, and so that's what we're going to create. We're going to create problems where the middle term is automatically going to cancel out, and the square root times the square root is going to turn into a normal number. So you're going to get rid of all the ugliness that you might see in the denominators of the problems today. That's the whole purpose. So let's say you had a denominator that looked like this example here. Radical 2 minus radical 3. Now, we are not able to combine a radical 2 and a radical 3 with adding or subtracting. You could multiply them, but you cannot add things that don't match. They're just like variables. So what we do is we would multiply by its conjugate, which is the same thing written again, but this time with an opposite sign. So if it was a minus, you would put a plus. If it's a plus, you would put a minus. You just change the sign to be the opposite, okay? When you multiply these two things together, watch what happens over here. And this is the cool part about this lesson. Remember how we FOILed or did the distributive property twice? Okay, we would have the square root of 2 times the square root of 2. That's going to create a normal 2. So there it is. When we do the FOILing and we go to this far term here, the square root of 2 times the square root of 3 would have been a positive square root of 6. When I come to the middle, the negative square root of 3 times the positive 2 is the negative square root of 6. Those guys canceled out, didn't they? Now we're on the last part. The radical 3, a negative radical 3 times a positive radical 3 is going to create a negative 3. There it is. When you add those two things together, combined like terms, you get a negative 1. So all of this ugliness right here, when you multiply it together, falls apart and turns into just a normal number. And it's kind of the shortcut. Remember when we had square the first, square the last, and put a minus sign? That's what you're doing. That's what you're going to do in the denominators when they need it, okay? So let's take you down to this problem here, all right? And this is the problem. Notice you have a binomial. You cannot add those terms together, so we have to multiply by the conjugate. And remember, whatever you do to the bottom, you have to do to the top of the fraction. So what would the conjugate be for this bottom part? The square root of 2 minus the square root of 5. And that's what they have done here. Okay? So here's the square root of 2 times the square minus the square root of 5 on both the numerator and the denominator. Are you with me as far as the setup goes so far? Now we're going to do the real math. We're going to truly distribute. All right? So we would have 11 times the square root of 11 times the square root of 2. That became the square root of 22. Then the square root of 11 times the square root of negative 5, that's negative. That's going to be a negative square root of 55. The top part was easy, right? All right. Now,
Miss Stevens?
yeah.
Stevenson, I mean?
Yeah.
Can you have David Young come up to the office for a minute?
Sure. Can he come get it after class?
Yeah, that's fine.
Okay. Good call there, mister. All right. So at this point, let's look at the denominator, how we would work it, okay? We're going to square the first term. Square root of 2 times the square root of 2 is a regular number 2, right? The middle terms are going to cancel out. And then the square root of 5 times the square root of a 5 is a normal 5. And we always have a minus sign. And so what is 2 take away 5? Negative 3. You finished your problem. You can't simplify the square root of 22 or the square root of 55, because if you took them to the division ladder, the only thing that's going to make a 22 is 2 times an 11, and the only thing that's going to make a 55 is a 5 times an 11. So nothing can be broken out of the jail or simplified. You're done. Okay? So let's look at the first try it here. I have a binomial with a radical sign. I need to use the conjugate. So what would it be?
4 plus the square root of 11.
Perfect. Top and bottom, right?
Yep.
So 4 plus the square root of 11 on the top, and 4 plus the square root of 11 on the bottom. Distributive question? You okay? Distributive property. 10 times 4 is 40. 10 times the square root of 11 is just 10 times the square root of 11. Now let's work on the denominator. 4 times 4. It's 16, right? Because this didn't have a square root on it. So a real 4 times a real 4. I know, but if it doesn't have a square root, you don't put a square root on it. You're still just multiplying the first term times the first term. Okay? All right. The middle term is going to cancel out. And now we're looking at the last term. The square root of 11 times the square root of 11 would give you a normal 11, right? And then what kind of sign will it be in the middle? A minus sign. So we're going to clean this up a little bit, and I would have a 40 plus 10 times the square root of 11 all over a 5. Okay. Now, on your homework, if you get such that the top term can be simplified truly both of them by the bottom term, go ahead and do it. But if only one of them can be simplified, don't do it. Just leave it as it is. Does that make sense? Yes, sir? You cannot. You cannot. Okay? You cannot add the 40 and the 10 together. Yes, sir? Uh-huh.
I ended up multiplying the 10 times the square root of 11, which got me 110. That square root of 110 would that?
No, that'd be very wrong.
Okay.
You can't. Yeah, no. You cannot do that. It's only square roots times square roots, normal numbers times normal numbers, and you can't add things that don't match perfectly. Okay? So these guys cannot be combined. However, can 40 be divided by a 5?
Yes.
Can 10 be divided by a 5?
Yes.
If you get yes to both of those, then you should go ahead and do it. And so what is 40 divided by 5?
8.
An 8. Okay. And what about 10 divided by 5?
10. I mean 2.
A 2. And if you want to put a 1 under it, that's fine, but it's certainly not necessary. Great final answer right there. You okay with that?
Next.
No, it's not bad. Okay, well, we're not there yet, so let's just sit tight, okay? Yes, ma'am?
So will that always be the case?
Here and here?
Yeah.
Sometimes it would work and sometimes I wouldn't. So let's make a pretend problem right now. Suppose this had been a 3 instead of a 10. This would have been okay, but since this one didn't work, we would have just left it like it is. We wouldn't try to do just one of them, okay? Only simplify them if both of them can. That way it'll be easier for us to grade and it won't be as confusing for some people, okay? All right, let's look at the second try it there. Now, Jay, did you have a question about the second try it?
Yes, I went ahead and started solving it.
Okay.
But for doing the 3 times the square root of 3 times the square root of 3, I'm wondering if that canceled the top one out too, since
It can.
it.
Okay. All right, so let's look at what would be the conjugate that we would multiply this one by. 2 minus the square root of 3, right? So 2 minus the square root of 3. That was an ugly parentheses. Okay. And we have to do it on the top as well. So distributive property. The square root of 3 times a 2 becomes a 2 square root of 3. You good with that? I just put them in the proper order. You know how we put it, like if we said x times 3, we wouldn't say x3, we would say 3x. You want to put your coefficient out in front of the radical or in front of your variable. And now I'm going to have the square root of 3 times the square root of 3. What's that answer going to be? A 3, and I would have a minus sign, right? So it's a normal 3. Now on the bottom, the 2 times the 2 becomes a 4. The middle term is going to cancel out due to the opposite signs. And then the square root of 3 times the square root of 3 becomes a normal 3, and it has a minus sign. So simplifying what we have, we would have 2 square roots of 3 minus a 3 over 1. Don't care if you leave the 1 or not, but you're finished at this point. It's going to, I mean, it's going to require you to think a little bit harder than this, but for the most part, this is the general idea, and it should not be horrible. All right? Right. Right. Okay. Any questions? You good? Stop. Okay. All right. All righty. Let me get you your worksheet. It's got 14 problems on it. I'm going to talk to you about the first ones.